Hey, what's up guys? This is the video for 1.7, which is functions, and today we are actually going to look at what is a function, why do we use functions, and how can we actually make a table from a function. So first, let's understand what is a function. So it says here that a function is a relation. So on the previous video, I showed you guys that a relation is just a set of points. You guys can change those points to tables and mapping and so forth, and you can also graph. But a function is one of those relations in which the input is paired with exactly one output. So what does it mean? Well, a function is when you can actually use one x value and every x value has exactly one y value. When you guys grab the table and you guys start connecting the points, you are going to start making a shape with those points. So you guys notice here on the graph that I'm showing you, the shape of this graph is a U-shape. It is a function. We have one that is a line, which is a linear function. We have one that looks like an S, which is an S function or a cubic function. But you guys need to understand that in order to make this graph, we actually need the points. We need a table or order pairs to graph the points. The mapping is more to check if you guys have a function, and if you have a function, then you can start graphing and making one of those shapes that represents a function. So that's what we have mapping here. And also you need to know how to differentiate if an equation is a relation or just a function. So we do have an equation here, and notice the notation that I have with an f parenthesis x. This is what is called a function notation, but we're going to get into that later on. So how do we know that something is a function? We know that a table is a function when the x values, you look at all the x values in your table and they are not repeating. So when they are not repeating, you say it is a function. The y values, yes, they can repeat, that's fine, but the x values cannot repeat. In mapping, if you guys have the domain, which is your x values, with one arrow going out, exactly one arrow going to the range, every x value has only one arrow going out, it is a function. So you guys will have one arrow going out, one arrow going out, and one arrow going out. If one of those numbers have two arrows going out, and I'm just going to draw one so you can see what I mean. Let's say that the -2 has a second arrow going out this way. So since it has a second arrow, two arrows going out, it is not a function. But if you guys have only one arrow, so let me delete that, then it is a function, only one arrow going out. Now for equations, there's a little bit more that you guys need to understand, and I will show you guys that later on. But what you need to know is that f of x is the same thing as y, and the y value cannot have a squared, it cannot have an absolute value, and you must have a y in your equation. So that's how you know it's a function. With the graph, you guys have to use a vertical line test to see if it's a function. So vertical line goes up and down, and we're going to talk about each one of them so you understand how to use each method to check if something is a function. So let's go ahead and start with the first example. So right now I do have a relation, so you guys can see a set of order pairs. 2, 1 is the first point, 3, -2 is the second point, 4, 1 is the third, 5, 3 is the fourth, and 6, 4 is the fifth point. So right now I don't know if it's a function, so I'm just going to put the name relation. Actually, let me just underline the word relation here. Okay, so it is a relation. Let's check if it's a function, and once you know it's a function, you can start graphing, connect the points, and make one of the shapes, or you can start predicting a y value for an input, an x value. Let's go ahead and look at the table. Okay, so I'm just going to make a table here. I also say t table once in a while. So I'm going to start making the actual x column, the y columns, x values, and y column and y values. So my first point is 2, 1. My second point is 3, -2. My next one is 4, 1, the next one is 5, 3, and the last one is 6 and 4. So I do have a table here. Now let's go ahead and do the mapping before we actually before I explain how do you know it's a function. So for mapping, I'm going to do my two bubbles. So I have one bubble here, and these are going to be my x values. My second bubble here, and these are going to be my y values. So let's go ahead and put the x's. I'm going to check that the x's are not repeating. Remember, in a mapping, if it's repeating, you just write it down once. So they're not repeating. 2, 3, 4, 5, and 6. And my y values, the 1 is repeating. So I'm going to put a 1. The -2, notice the 1 is repeating here, so you just write it down once. The 3 and the 4. I'm going to start connecting the x's to the y's. So the 2 goes to the 1, 3 goes to -2, 4 goes to 1, 5 goes to 3, and 6 goes to 4. Okay, so here's what we look for to know if it's a function from a table. If you guys have a table, look at the x values. If the x values are not repeating, yes, it's a function. From mapping, if you guys have the x, which are the domain values, the x values only has one arrow going out. So one arrow going out every time, yes, it is a function. So I'm going to say this relation, the one that I have up here, which is the same thing as the table that we made, or I made, and the same thing as a mapping, I'm going to say it is a function. It's a function. Because in the table, the x's are not repeating. In mapping, the x's only has one arrow going up. Another method you guys can use to check if you have a function or not from a graph is using the vertical line test. So on the previous example, we didn't have a graph. We had a set of ordered pairs. But now we have two graphs. Notice the first one is a U shape. The second one kind of like a V sideways. So you guys can see it's a function, the U shape, and not a function, the kind of the V shape going to the right. But why is this one a function and why is this one not a function? Using the vertical line test, you guys will use a vertical line, and if that vertical line touches the graph only once as you move from the graph to left from right, then it is a function. So I'm going to give you guys an example of a vertical line on this graph here. So if you draw a vertical line, I'm just going to make a red vertical line. Notice the red line crosses the graph once. I'm going to draw another one, another vertical line. So notice that the second vertical line, it touches once. I'm going to draw another one. So no matter what, when I draw that vertical line on that graph, it only touches once. So that's why this is a function. It passes the vertical line test. It only touches once. Now the next one, when I draw a vertical line right here, it touches 2 times. So since it touches 2 times, it's not a function. You guys can draw another one here. So when I draw the second one, look, 1 time, 2 times. So it touches the graph 2 times. Now you might be asking, well, what happens at the origin? If I draw that line on top of the y-axis, crossing the origin, well, yeah, it touches once, but when this vertical line moves to the right and becomes this one, now it touches 2 times. So that's why it's not a function. When this line moves to the right and now it becomes this line, it also touches 2 times. So if you move the vertical line to the right or along the graph and it touches twice anywhere, then you guys say that is not a function. So let's go ahead and practice. I'm going to give you guys some graphs and we're going to check if it's a function or not a function. So you guys see the graphs here, and I'm just going to go to a couple here, but let's see the first one. The first one, well, you guys would draw a vertical line, and I'm just going to draw one here. Notice it touches the graph once, which is the line. This one here, that's your actual graph. and we just want to know how many times it touches. You guys do another vertical line and it touches once, another vertical line and it touches once. So it is a function. The second graph is kind of like a wave, but we want to check if it's a function. So I do the same thing. I draw a vertical line. Hey, touches once, another one, touches once, another one, it touches once, and I'll do one more. It touches once. Okay, so since every vertical line touches the graph once, then it is a function. Now sometimes you might encounter those graphs where it's not a function. So notice this one. It's not the V shape, it's a U shape sideways. But when you guys draw a vertical line, you will see that it touches twice. So right there, we say not a function. Now, if you guys don't have a shape, you just have order pairs or points on your graph. Well, you're going to have to shake every point on that graph and make sure that that 2 points are not on the same line. So I'm going to draw a vertical line on each point. So notice the first point, there's only 1 point on that vertical line. My second vertical line, there's only 1 point. I have another one here, and there's only 1 point on that one. And I'm going to check the next one, only 1 point, only 1 point, only 1 point, and 1 point. So this graph is a function. There's only 1 point on that vertical line. Okay, now let me show you guys one where it's not a function and you guys also have points. Now this one here, when I draw the first line, yep, you see that there's only 1 point on that vertical line. But when I do the second vertical line, notice there's the first point, second point, and I'm just going to make those red so you see them. There's 2 points on that line. I'm going to make another one. Look at this one. 1 point, 2 points, 3 points. So on this one, there's actually 3 points on the same line. So this graph is not a function. So you just have to check if you guys have 1 point or 2 points on that function. Let me show you guys this one here, because this one, we are looking at this line here. So we want to know what happens when we draw a vertical line on this line. That's your graph. It's a vertical line. So let me just do a vertical line up and down. And notice that I'm touching, as I draw the line, I am touching the graph all the way. So since the vertical line touches the graph all the way, this one is not a function. Okay, now another method. You also have to know when you have an equation if it's a function or not. So how do you check when you have an equation? Well, I want you guys to ask 3 questions. When you ask, number 1, make sure to check if you are missing the y. Number 2, make sure to check if the y has a square. Number 3, make sure to check if the y has an absolute value. If you answer no to all the questions, then you can say it is a function. So let's look at this equation first. Are you missing the y? No. Does the y have a square? No. Does the y have an absolute value? No. So that means that this one is a function. Let's look at the next equation. Are you missing the y? No. Does the y have a square? No. Does the y have an absolute value? No. So this one is also a function. So notice what the equations look like. The first one, y equals 3x plus 8. The second one is y equals negative 13. Different equations, but they're both functions. Now look at the next one. X plus 1 equals y squared. Well, are you missing the y? No. Does the y have a square? Yes. So right there, guys. So we answer yes. We say not a function. The next one, x squared equals 15. Are you missing the y? Yes. There's no y here. So we say not a function. And the last one, guys, x squared plus y squared equals 4. Are you missing the y? No. Does the y have a square? Yes. So this one, not a function. So I show you guys how do you know if a relation, a graph, and an equation is a function or not. So why is this important? Well, we're going to start making tables. We're going to start predicting. I'm going to give you guys an x value, and you need to find the y value. We are going to have a domain, and we need to find the range. I'm going to give you an input, and you guys need to give me an output. So if we know it's a function, we are going to be able to graph and make a shape where we can start predicting the y values or the range depending on the domain. Alright guys, I'm going to have to make a second part of this video, and the second part is going to be function notation and how to actually evaluate functions. So make sure that you guys practice, and I'll see you guys later.